All right, as you are finishing up there, we're on page 314, lesson 21. I'm going to still talk about some tendencies of rational, irrational numbers. Can you combine them? Can you not? How do you know? So the first example here, it says here's some integers, positive or negative integers are all listed here. It says experiment with adding any two numbers from the list. So basically, can you add integers? So let's just pick a couple examples. Let's do 40 plus 5, and let's do 9 plus negative 10. What are the answers to those?
45.
Negative 1. Negative is bigger there. Are those both integers, those answers? 45 and negative 1 integers? Yeah. So if you add two integers together, you should get another integer. It says add up a number that is not an integer. Do we see any numbers that are not integers in our list?
What is that?
Integer is like 1, 2, 3, 4, going on forever, and the negatives. Nice numbers.
So really any number that's not a decimal
Or a fraction.
or a fraction.
So they are all integers, so you can't even do that from the list because there's nothing there that's not an integer. Multiplying. Again, I can just pick a couple here. Let's go 5 times negative 2, and let's do negative 10 times negative 1. 5 times negative 2 is negative 10. Negative 10 times negative 1 is 10. Again, those are both integers. And again, you cannot do 2b because we don't have anything in our list that's not an integer. Question number 2. Are these rational or irrational if you combine them? And how do you know? So 4 plus 0.175. Those are both rational numbers. It tells us right here. So the question is 4.175 a rational number? So it's yes or no. Why? It is a terminating decimal. It means it stops. You also could write that as a fraction. So that is another reason all rational numbers can be written as a fraction as well. So I would agree that that is rational. How about B? Is 13 over 10 rational?
Yeah.
Why?
Because it's
It is written as a fraction. You could put it in a decimal form. It's 1.3 repeating. It's another way to tell. C is an easy one. Of course, 1 is. 1 is an integer. Could also be written as a fraction, right? 1 over 1. And how about D? The trick is this statement right here. As long as A is an integer, that means you're adding two integers. Your answer would have to be as well. If it didn't say that, then A could be like the square root of 2 or something, and that would change it. But it says A is an integer, so that one has to be rational as well for that reason. All right, we are going to skip top of page 315. Actually, all of 315. And go right into 316. I'm not a big fan of the way they explain this one. But all I want to look at is this one. And I want to know why that's irrational. Because you don't know what the square root of 2 is. I think that's a lot easier than looking at their explanation. This is irrational. Irrational plus, I don't care what this is. It doesn't matter. You're going to get irrational. The only exception to that is that when we talked about it yesterday, if you take the square root of 2 plus the negative square root of 2, then you get 0. That is the exception. Of course, 0 is an integer, and that is rational. My answer going to be irrational or rational here? Irrational. How about here? Irrational. What? It's got a square root.
We know it.
Oh, you know that one. You know the square root of 4. That would be rational. Top page 317. Consider the following equation. Find a value of b so the equation has 2 rational numbers or solutions. So a number that'll work out really nice. So I'm looking for a middle term here. To me, it'd be easier just to factor it. Maybe the factors of 4. Let's just throw one out there. Give me factors of 4x. 4x and 1x. Georgia will use yours for this one because I believe it is a perfect square trinomial as well. Factors of 9. 3 and 3. Sure. So if I was to solve those, my answer would be negative 3/4 and negative 3. 2 nice rational solutions. So why don't you tell me what the middle term would be here if I were to FOIL it or diagram it based on those numbers you gave me.
13.
Oh, wait, the 4 exchanges.
15. Or, yeah, 15.
Should be 15. 12 plus 3. So if B was 15, I'd get 2 rational solutions. Okay, let's go down to C. Let's make it a perfect square trinomial. I know I will only get one solution if I get the exact same thing here. So the square root of 4x is 2x. Square root of 9 is 3. What would my solution be? I only get one solution of negative 3/2. What's my middle term there?
12x.
Be 6x and 6x, right? So it'd be 12. All right, so to get irrational here. I'm going to have numbers that don't come out very nice. So you'll notice that 15 worked out really nice. So basically anything that won't factor. So I could put in a huge number, factors of 4 and 9, that would get me to, I don't know, I could say like 55. There's no way to get to that factor. That would be irrational numbers. Pretty much anything that we haven't tried would work and give you something that's irrational, because you're going to have to say have a square root. That doesn't work out. No solution. So no solution would be the other way. I need a small number, and small number of b. 1. And again, we could just show that. Let's say it is that, just to confirm it. Negative b plus or minus the square root of b squared. Negative 4 times a times c all over 2a. You can see that this is going to be a negative number. That is your goal when you want no solution. This needs to be negative. So those are just trial and error. The two that I'm probably most concerned with would be those two. We've done a lot of those. Remember, if it's one solution, they both need to be the same. That is helpful. And only certain numbers work for that as well. So let's take a look at the homework. See if any of these need to be adjusted. One is matching. I think you can handle that. 2, consider the statement. Irrational number times irrational number makes an irrational product. So you're looking for ones that do that. So both numbers have to be irrational, and then you will get a rational product because it wants you to circle the ones that are false. Okay, so which ones are false? So let's look at A.
Well, square root of 4 isn't.
Square root of 4 is not irrational, so that's not even a choice.
So that wouldn't be circled, that's false?
No. Because you're looking for irrational times irrational equals rational. That's what you're looking for.
But it says circle ones that show that it's false.
Yeah, that's not showing that statement's false. They didn't even follow the directions. So B, is that irrational? Irrational? Is this irrational? Is this irrational? Do I get a rational number? What's square root of 7 times square root of 7? This was your specialty yesterday.
It's 7.
7. So that one would be false because you get a rational answer. So that's what you're looking for there. You're looking for this to be true. There are more though. There are more. Question 3, a review. Again, we'll talk more about vertex form tomorrow. Question number 4, just rational, irrational. Question number 5. 5 is not multiple choice. You're finding an example, just one, that makes the statement false. I don't like number 6. Let's change that one. Georgia can give me an equation.
Oh, I sure can. X squared.
Actually, I'm going to change it. With that equation in standard form for me. That's what I want you to do for number 6.
So you want us to
Foil it or diagram it.
you just want us to go?
Yep. 7, I think we can handle. does go on to the next page there. Don't forget B at the top. And question number 8, match each graph with an equation. So graph A, B, C, D with the correct equation. Those are in vertex form. Again, that's a good review for tomorrow, how to go from standard to vertex. And that is it. So 1 through 8, quite a bit of time here for you to work today.